These are the notes for section 5.5 and 5.6 that we did on, I think, Tuesday of this week, whatever day you were gone that you missed, Michaela. As you watch this, if you need to rewatch an example or pause it, rewind, whatever, just feel free to do that. I just thought I would go through the notes with you so you could watch them and be able to do the assignment. In section 5.5, it's about comparing the lengths of sides and the size of the angles in just one triangle. And if you look at the first picture here, I'm experimenting here, sorry. If you look at this first picture, the red side they've indicated as the longest side, and notice it's opposite of the largest angle if you look at the opposite side over there. And it's going to be the same, the shortest side is going to be opposite of the smallest angle, and vice versa. If you know that this is the smallest angle, then just look straight across and that's going to be the shortest side on the other side. If you look at the first example, it will have, I don't know how to scroll down. You can tell this is the first time I've used this. Not sure how to make it go down. But anyway, in this triangle, it says put the angles in order from largest to smallest. I wish I would have made that smallest to largest, because in the bookwork it asks you to do it from smallest to largest. But what they've given us on this is the lengths of the sides. And since I want the largest first, on my example here, we'll just have to look for the largest side, which is this 20. And you just look at the opposite angle to that. So that makes angle B the largest angle. And then the medium-sized angle will be the one across from the medium-sized side, which is this 18. So if you look at the opposite side there, that would make angle A come next. And then 3.7 is the shortest side, so that makes angle C the smallest angle. So that would be the angles in order. Okay, the next, I guess, example was actually a theorem here. Deals with just if you know two sides or two angles in a triangle. It's the same idea that like if you look at the first picture there, 10 right here is, let me see. The 10 right here is bigger than the 8. So if you look at the sides opposite, since 10 is bigger than 8, if you look at this angle opposite, that means angle A is going to be bigger than angle C. You just got to make sure you know how to look to the opposite angle. And then vice versa, since 80 is bigger than 60, if you look at the side opposite, that means this line here, BC, is going to be bigger than the one opposite angle, that 60-degree angle, which is AB. So that's what is written right there. Okay. The next theorem, which is pretty important actually, just says that in any triangle, we're down here at this one, in any triangle, if they give you the lengths of the sides, when you add any two of them, it has to be bigger than the third side. And you're supposed to, technically, you're supposed to do it for every side. So let's say, I'm just making up numbers here. Let's say this is 5, 7, and 9. What has to be true is that when you add the 5 and the 7, it's got to be bigger than the 9, which it is, because 5 plus 7 is 12, so that's bigger than 9. But you have to do every combination. So the next one would be like doing 7 plus 9 has to be bigger than the 5, which it is. And then the last combination is the 9 plus 5 has to be bigger than the 7, which again, that is too. But a shortcut, when they actually just give you the actual numbers, like 5, 7, and 9, is as long as you did the smaller numbers adding up to something bigger than the longer one, then the others will work also. So but that only works if they only give you the numbers. So if they give you algebra stuff, you actually have to set up all three situations. Okay, a couple of review examples. Example number 1 here, it says in triangle ABC, and then they give you lengths of sides. So on a problem like this, it's going to be easier if you actually draw the triangle out. And then they say AB is 12, BC is 8, AC is 14. If one angle is 86 degrees and another is 35, find the measure of angle A, angle B, and angle C. So this is going to use the idea of that across from the longest side, which would be that 14, will be the biggest angle. Okay, but we don't know yet if 86 is actually the biggest angle because we don't know all three angles. So first you have to find that third angle. So what we'll do is we'll add the 86 and the 35. So that'd be 121, and then take 180 minus 121, which would be 59. So that third angle is 59 degrees. So between the three angles that I've circled there, the biggest one would be 86. So that means that angle B there will be 86. 59 will be for the medium, which is going to be across from the 12. So that would be angle C. That'll be 59. I've got to work on my handwriting. And then 35 is the smallest, so it'll go in that corner. Okay, next example says, is it possible to construct a triangle with the given side lengths? So this uses the theorem that says you have to add any two together and it'll be bigger than the third. So for this first one, if you add the 3 and the 4, it's got to be bigger than the 5. And again, when they actually just give you the numbers, that's really the only one you have to deal with, is adding the two smaller ones to be bigger than the larger one. And since that's a true statement, your answer is yes. That can make a triangle. For the next example, number 5 here, no, that's not number 5. For the next example, if we add the 5 and the 10, it's got to be bigger than 15, which it's not. So the answer is no. Okay, the next idea just kind of explains how our shortcut is going to work that I'm going to explain here in a second. Okay, so what I've done, it says if given two lengths, you can find possible values for the third side. Okay, so let's say they give you the 5 and the 9 for two sides, and we're trying to find the third side. Well, what's going to happen if two lengths that you know are 5 and 9, either 9 is the longest side, so the missing side is actually smaller than 9, or the missing side is our longest side, which would make it bigger than the 9. So I've drawn two pictures down here, try to point them out here, where the first picture I have 9 being the longest side, and X represents a side that's smaller than the 9. And the other situation is where that missing side could possibly be the longest side. And earlier when we did example 2 up above, I reminded you that really all you have to do is add the two smaller sides, and it's got to be bigger than the longer side. So for this first triangle right here, if you add the X and 5 together, it's got to be bigger than 9. So that's what I wrote right there. And then when you subtract 5 from both sides, that gives you that X is greater than 4. Now if you look at the second triangle, I've drawn it to where it shows our missing side as the longest side. So what has to be true there is that when you add the two smaller sides, the 5 and the 9, it's got to be greater than X. So that's what I wrote right there. And if you just add the 5 and 9 together, you get 14. So 14 is greater than X. Or you could switch it around and saying that x has to be less than 14. And then what you do is you put those both into just one inequality, and it looks like this one right here. So your final answer is actually that right there. Sorry about that. Still learning how to do this. Okay, so like I said, this is your answer right there. So the final answer, the shortcut, is if you're given these two sides, you just put x in the middle. I'll just rewrite it here. Put x in the middle, and put those two signs, and you add the 5 and 9 to get the big number, and subtract the 9 and 5 to get your small number. Okay, so example 3 says a triangle has one side of length 11 and another of length 6. Describe the possible lengths of the third side. So all you do, when they actually give you two sides, put x in the middle. You add these two numbers to get the big number, so 11 plus 6 is 17. And then you subtract them to get the smaller number, so 11 minus 6 is 5. And that's all you have to do. There's no work to show whatsoever. Just do that. Okay, the next example, same thing, except this has algebra in it. And since we don't actually know the sides, and we don't really know, even though it looks like the x plus 8 is the longest, there's no guarantee that I drew it correctly. So we have to set up all three combinations. And remember, the rule is when you add any two sides, it has to be greater than the third. So the first combination, let's add this one, and it's got to be bigger than the third over here. So it's going to be x plus 8. So those are these two sides. That has to be greater than the 3x minus 14. And then you have to solve that. So you put your like terms together. And then you got an x on both sides, so you got to subtract one of them away. So I'm going to subtract my 2x away. So I get 8 greater than 1x minus 14. Add my 14. So I get 22 is greater than x. So there's one combination, but you have to do all three. So let's say this time I add this one, and it's got to be bigger than the third. So if I add the x plus 8 and the 3x minus 14, it's got to be greater than x. So combine my like terms, so I get 4x. 8 minus 14 is negative 6. That's got to be greater than x. I'm going to subtract x from both sides and get my 3x. And then I'm going to go ahead and add my 6. So I get 6 over here, divided by 3. So I get x greater than 2. So there's my second possible answer. And then the third, I'm going to have to erase some of this, but I want to keep my answers. So I hope this isn't confusing when you watch it. So I'm going to erase this one here. And I got to do my third combination. And I believe the one I haven't done yet is adding this one and this one. So we're going to do 3x minus 14 plus x has to be greater than the x plus 8. Oh, I don't know what I did there. X plus 8. Oh, wow. Sorry if I made you dizzy there. This is the first time I've tried making a video. And then we combine our like terms, so we get 2x minus 14 is greater than x plus 8. Subtract my x, so I get 1x. Go ahead and add my 14. which would be 22. I already did that one. Did I already do that one? I guess I already did. No, I must have done something wrong. 3x minus 14 plus x is greater than x plus 8. Combined like, oh, that's a 4x. See where I messed up right there? Did you catch that mistake, Michaela? I didn't. Okay, so 3x plus x, that should be a 4x right there. Let me erase that. So then when I subtract x, I get 3x. That's better. Okay. Then 8 plus 14 is 22. And then I got to divide by 3. So I'm going to write my answer over here. So we get x is greater than 22 divided by 3 is 7 1/3. So there's my third part of my answer. And again, I'm going to have to erase. Okay. So what you do at this point, this is quite a bit of work, I know. And in your homework, there's 2 of these that you have to do. Okay. So how we got our 3 answers here, we need to combine those into just one final answer like this. So what you do is, man, this is sloppy handwriting, but this x is, even though this is written backwards, this says x is less than 22. Okay. And that's the only high number they give us, so that's our high number. And then what you do is between the 7 1/3 and the 2, you cross out the big number and don't use that at all. So the 7 1/3 is our small number, and that's your answer. And I apologize that that's so sloppy, but you can rewind that and hopefully make sense of everything there. Let me write that a little neater. So your final answer would look like that. So you set up all 3 combinations, solve them all out, and between the 3 numbers you cross off the smallest one, and then use the bigger number at the right, the medium number, that's 7 1/3 at the smallest end, and then that's your answer right there. Okay, the last little part of the notes is called the hinge theorem, and it's kind of a common sense one too. These deal with when you have 2 triangles, and what has to happen in the 2 triangles is you have to have 2 sides that match up. So notice here, length AB and length DE are shown to be congruent, and then BC and EF are shown to be congruent. So you have to have 2 sides in one congruent to 2 sides in the other. And then you look at the angle that's in between both of them, and those are the angles you actually compare. So since angle B is 55 and it's smaller than the 98, so that makes angle B smaller than angle E, when you look at the sides opposite, that makes their sides go in that same order. So AC will be smaller or less than DF. So that's what I wrote right there. When you have, if you look at the last example here on the right, again we have 2 triangles, and see how they share that middle side. So in the top triangle, between the 2 sides that are marked, we got to look at this angle right here, at angle C. And in the bottom triangle, again, the 2 sides that are marked, you got to use the angle that's between them. And then you look at the sides opposite. And since 16 is bigger than 15, that means the top angle is bigger than the bottom angle. So you would write that angle ACB. I don't know what I'm doing to make that jump like that. Angle ACB is bigger because it's across from that 16 than angle ACD. Okay, now in your homework there's a few that get a little tougher than that, but those are the main ideas. And there is your assignment. And I'm sorry it took 20 minutes for you to watch this video, but I just thought I'd give it a shot and see if maybe that helps you understand the majority of the homework. Have a good weekend.